We're going to look now at solving exponential or logarithmic equations that are in quadratic form. So let me give you a couple of examples. Here we have e to the 2x minus 5e to the x plus 6 equals 0. There's no way to combine different exponential functions that are subtracted or added unless they have the same exponent. Like if I had e to the x plus e to the x, that would be 2 times e to the x, for example. But this is e to the 2x and this is e to the 1x. So there's no way to combine those. What I want to point out is that e to the 2x is the same thing as saying e to the x squared. And then this is minus 5e to the x plus 6. And I'm going to do something called U substitution. And I think I'm going to erase this one right now because I'm going to need to kind of go over to the side. U substitution, and you could use any variable besides u, but it's basically taking a variable and substituting it for a more complicated variable to make the equation look simpler, and then you insert it back in later. So I'm going to say let u equal e to the x. I'm going to use the variable u to substitute every place there's an e to the x. So I'm going to say this is u squared minus 5u plus 6 equals 0. And from there, it's clear that this is a quadratic equation. It's a quadratic equation where we have an e to the x squared and an e to the x instead of just a single variable. So if I factor this, this would be u minus 3 times u minus 2 equals 0. So u is equal to 3 or u is equal to 2. And I kind of glossed over the fact that I'm saying u minus 3 equals 0 or u minus 2 equals 0, therefore u equals 3 or u equals 2. Now I want to know though what x equals, not what u equals. So I need to go back to this little substitution I did and substitute back. And so now I'm going to say e to the x equals 3 or e to the x equals 2. Now I need to solve those two equations and say natural log of 3 equals x or natural log of 2 equals x. And so those are my two solutions, and you can get the decimal form of those. But those are my two solutions. Let's look now at a logarithmic equation that is in quadratic form. So here's my equation. Log of x cubed is equal to the quantity log of x squared. Okay, notice the difference here. The cubed is inside the log. It's inside the argument of the log. Here the entire log expression is squared. So what in the heck do I do with that? That's kind of a weird one. Okay, well, if this were a log x and this were also some sort of log x, I would have a log x squared and a log x that isn't squared. I could maybe think of quadratic form here. So I'm going to do something with this exponent. I'm going to move it out in front and say this is 3 times log x equals log of x squared. So I have a log x and a log x squared. So I'm going to say let u equal log x. So I have 3u is equal to u squared. Now I'm going to caution you here, don't divide both sides by u and say 3 equals u, because that would give you one of the solutions, but it wouldn't give you the other solution. When you have a squared term, you have two possible solutions. So let's double check this. So we have, let's set it equal to 0, u squared minus 3u. Let's factor out the u times u minus 3. So u equals 0 or u minus 3 equals 0. So I have two possible values for the variable u, but u equals log x. So that means log x is equal to 0 or log x is equal to 3. Since I used, this is a base 10 log, that means 10 to the 0 equals x, or 10 to the third equals x. So my two solutions are 1 or 1,000. Okay? Neither of which makes the denominator equal to anything inappropriate, so we can say, so this is basically saying log of 1 equals log of 1 squared. Well, log of 1 is 0, and 0 equals 0 squared, so that's fine. Log of 1,000 cubed. Well, log of 1,000 cubed would be log of a billion. Would be log of, let's see, 1,000 cubed, 1,000 times 1,000, 1,000 would be 10 to the third, that'd be 10 to the ninth, basically. So that would just be 9. Log of 1,000 would be 3. 3 squared is 9. So those both check. Okay, so those are just a couple of examples. Being able to recognize when you have something squared and the same thing not squared in the same equation, you can do a quick substitution, solve it as a quadratic, substitute back, and finish solving. So there's exponential and logarithmic in quadratic form.